Hello student, I am Dr. Ajay Kumar Sinha. Now I am going to discuss I will continue from the last class and now I am going to discuss valence bond theory. Last class I have discussed these shapes of molecules containing bond pair and lone pair. Now I am going to discuss valence bond theory. As we know that Lewis' approach helps in writing the structure of molecules, but it fails to explain the formation of chemical bond. It also does not give any reason for the difference in bond dissociation enthalpies and bond length in molecules like hydrogen. In hydrogen, dissociation energy is 435.8 kilojoule per mole. Then Lewis' approach does not tell anything about this. And also fluorine, it has 155 kilojoule per mole and bond length is 144 picometer. But Lewis' approach does not tell. Although in both the cases a single covalent bond is formed by the sharing of an electron pair between the respective atoms. It also gives no idea about the shape of polyatomic molecules. These are the weaknesses of Lewis' approach. Question sometimes is asked in medical, IIT, UPSC and even in CSIR-NET exam. These questions are asked. Hence you should be careful. Listen carefully. Similarly, the VSEPR theory gives the geometry of simple molecules, but theoretically it does not explain them, and also it has limited application. See, this is the weakness of VSEPR theory. Always weakness, limitation will be important. Okay, in a simple way. Then VSEPR theory, it gives the idea about the geometry of simple molecules, but theoretically it does not explain them, and also it has limited application. To overcome these limitations, and how you will overcome from this limitation? To overcome this limitation, the two important theory based on quantum mechanical principle are introduced. Based on quantum mechanical principle. What are that two theories? Both theories are very, very important. These are valence bond theory and second molecular orbital theory. One by one at the right time I will discuss, but now valence bond theory I am going to discuss. Valence bond theory was introduced by Hitler and London in 1927. These are the name of scientists, Hitler and London, in 1927, and developed further by Pauling and other scientists. A discussion of the valence bond theory is based on the knowledge of, listen carefully, discussion of valence bond theory is based on the knowledge of first, atomic orbitals, second, electronic configuration of elements, third, the overlap criteria of atomic orbitals, fourth, the hybridization of atomic orbitals, and fifth, the principles of variation and superposition. These 5 things you have to understand. Knowledge of all these 5 things you should know. That's why slowly and slowly, to understand better, I will discuss all these 5 points. Okay. A rigorous treatment of valence bond theory in terms of these aspects actually is discussed in higher level, that is for just UGC CSIR student, net, those who are preparing for CSIR-NET, for them this rigorous treatment of valence bond theory in terms of these 5 points are discussed. Actually, this is the mathematical treatment. Here you don't require so much depth study. Here you require in terms of qualitative and non-mathematical treatment only. Details, it is only for CSIR-NET students, aspirants, those who are preparing. Here you require only just qualitative and non-mathematical. Mathematical they require. Okay, I will discuss separate for them. To start with this, you can say consideration, the formation, we will consider only formation of hydrogen molecule. Actually, it can apply for others also, but they are very complicated, very distinct, mathematical. Hence, hydrogen molecule is simple. Hence, all things we will discuss keeping in mind hydrogen molecules. Okay, formation of hydrogen molecules, which is the simplest of all molecules. Okay, now listen carefully, it is full of concept. Consider 2 hydrogen atoms A and B approaching each other having nuclei Na, capital N, capital A, downright A, means first atom of hydrogen, and Nb for second hydrogen of atom. Also you consider, and electrons present in them are represented by a small e capital A, means electrons of atom A. Similarly, a small eb means electron of atom B. This you have to consider 2 atoms, atom A, atom B, both are hydrogen. Then actually you have to consider that how nucleus, actually you know that in atom, in any atom, nucleus will be there. On nucleus, proton and neutron will be there. Actually there are 17. Many particles are there, but in lower level, you study only, you can say that nucleus is made up from proton and neutron, but that is not only correct. Many particles are there. But here you consider only that on nucleus, proton and neutron is there. Okay, and electron is revolving around the nucleus. E. Electron means E negatively charged, proton is P positively charged. That's why nucleus is considered as a positive charge. But here you consider 2 atom H, HA, HB in that nucleus. That nucleus you consider as a Na, and other you consider as a Nb. Now here what happens, it is already I have given hint in any other lecture previously I told. Now here is the right time to tell. Then here what will happen, that here you are going to consider attraction and repulsion. Then in molecule A, proton is there, neutron is there, proton is there, electron is there, a positive charge. You can tell nucleus is positively charged. Nucleus is positively charged because proton is positively charged. Then here one, you can say, attraction will be between nucleus and electron, correct? and repulsion will be also there. In the same charge, repulsion will be there. Then electrons repulsion, and positive and negative means nucleus plus electron attraction. This happens in any atom. In any atom this happens. Then here you are considering two atoms, A and B. Then what will happen when both atom will approach to each other? If they will come closer to each other. If they are very far, there no effect. No effect. But if they will come closer to each other, then they will feel two type of force. Attractive force as well as repulsive force. Then how? Then now you can understand nucleus of first atom and electron of second atom. Correct? There will be attraction. Due to that they will come closer. Other attractive force, then again nucleus of other nucleus B, HB, nucleus of B atom and electron of A atom, both will again attract. Then this is the total attractive force due to nucleus and electron, due to both atom of hydrogen. Similarly, there will be repulsion. How? Then both atom when they will come closer to each other, the nucleus of both atom, both are positive and they will repel. One repulsive force. Second, electrons of first atom and again electrons of second atom, both will repel. Then repulsive force is also due to the electrons. Then here I told you for the attractive force how it develops, and repulsive force how it develops, I have told you. Correct? And here only I want to tell you that it is observed that attractive force is larger than repulsive force. This you keep in mind. That's why they are somewhat close. Both H atoms are close. Now I will just go ahead from this. Then I told about the attractive and repulsive forces between the, you can say, both atoms. I have already told you that it has been found that magnitude of new or old attractive force means in the what is the same atom attractive and repulsive force, that is called the new, old, because always they will be together. Then each atom attractive and repulsive force will be there from the beginning, then that is called old. But when new atom will come, that time force or repulsive force and attractive force is called new, with neighboring new. Okay. Then experimentally it has been found that the magnitude of new attractive force is more than the new repulsive force. Means simply you can tell when two atoms will come, then attractive force will be more than repulsive force. As a result, two atoms approach each other and potential energy decreases. You know that to make the stable molecule, potential energy should decrease. If more the decrease of potential energy, more the stability. That you keep in mind always. Okay. Then as a result of two atoms approach each other, potential energy decreases. Ultimately, a stage is reached where the net force of attraction balance the force of repulsion and system acquires minimum energy. Energy will be less. That's why molecule will be stable. More the less energy, more the stability. Okay. At this stage, two hydrogen atoms are said to be bonded together when energy is minimum. Then you can tell at this stage two hydrogen atoms are said to be bonded together to form a stable molecule having the bond length of 74 picometer. This question is again asked, one mark question. Bond length of hydrogen molecule HH. What is the bond length? Because this is a common. Hydrogen molecule is common. Hence, for related to hydrogen molecules, you should know all the things. Then 74 picometer. Since the energy gets replaced when the bond is formed between the two hydrogen atoms, the hydrogen molecule is more stable than that of isolated hydrogen atom. When hydrogen atoms are separate, hydrogen atom, not molecule, atom, when both are separate, that is called isolated. Then that time energy may be less, more, but you can say, or since the energy gets released when the bond is formed between the two hydrogen atoms, energy is released. The hydrogen molecule is more stable than that of isolated hydrogen atom when they were separate. The energy so you can say released is called the bond enthalpy. Already I have discussed. The energy so released is called bond energy. Then in any bond formation, energy is released. Energy is released. That is called bond enthalpy. The energy so released is called the bond, you can say, enthalpy. And if we will see the graph, which I will try to give some graph, which is this you can say, because energy is released, then in molecule energy will be less and molecule will be stable. Then in the graph you will see which correspond to the minimum in the curve. If you see the curve, then I will try to give the curve. Then in the curve it will go just like V you are writing. Then in the graph it will go from the high, it will come low, slowly low, it will come to minimum. Again it will go slowly and slowly to rise. Just like you can say, like V. First from the high it will come slowly and slowly down. Minimum. Again from there it will slowly it will go up. It will give a just like a V shaped. Okay, not exactly V, but it will not pointed, but it will go minimum, again it will rise. Okay, that shows about the, you can say, least energy. Then now I have discussed about the, you can say, valence bond theory. Just I have discussed, I have given only basic idea I have given. It is not complete. VBT, that it is only just idea I have given you. Now actually it requires, I have told you five points. As for example, already I told you, orbital overlap concept you have to know. Directional properties of bonds you have to know. Overlapping of atomic orbitals you have to know. And types of overlapping and nature of covalent bonds you have to know. Then today many things you have to understand very clearly VBT. Then now I will give now idea of two things, orbital overlap concept and directional properties of bonds. This today I will give the idea. Okay, and now I am going to discuss orbital overlap concept. Now listen, in the formation of hydrogen molecule, there is a minimum energy state when two hydrogen atoms are so near that their atomic orbitals undergoes partial interpenetration. Penetrate means they will come very close. That is called interpenetration. This partial merging of atomic orbital is called overlapping of atomic orbitals, which results in the pairing of electrons. Single electron, they will paired up. That actually you have this terms you are knowing, but this is what happens that they will come very close, and two electrons, they will come very close to each other and bond will be formed. This bond forms due to overlapping. Here this is the important. Two orbitals will come very close, and but they will not touch. That you keep in mind. They will not touch. They will come very close. Then partial merging of atomic orbital is called overlapping of atomic orbitals, which results in the pairing of electrons. The extent of overlap decides the strength of a covalent bond. In general, greater the overlap, the stronger is the bond formed between the two atoms. Therefore, according to the orbital overlap concept, the formation of a covalent bond between two atoms results by pairing of electrons present in the valence shell having opposite sign, not same sign, opposite sign. That is I told you na, clockwise, anti-clockwise, spin. Both hydrogen are there. Here you have to understand very interesting things. Both have one electron. Then who will come closer to each other? They will tell, ego will develop. Why should I go there? Other atom also will tell, why should I go there? Then despite that, hydrogen atom is forming. H2 molecule is forming. Then how? Then here you can understand both hydrogen, both are in hydrogen orbital, one electron is there, but both electron have opposite spin. One have plus half, then other have minus half. That's why both are coming close and bond is forming. Not the same. It's not the same spin. Opposite. Okay, opposite spin. This is very important things. I have told you. Question is also asked, and particularly for IIT. In IIT, some question they will put may advance. I am talking about in advance. They will ask only this type of question. Now I am going to discuss directional properties of bonds. Directional means it will tell about the direction, that in which direction they will make the bond, means overlap. This will come, orbitals will come, then in which direction they will come. For the direction, for the formation of bond, orbitals should come in a proper direction. Only then bond will form. They will overlap. Then here discussion is related to that. As we have already seen, the covalent bond is formed by overlapping of atomic orbitals. The molecules of hydrogen is formed due to the overlap of one s orbital of 2h atom. Already I told you. In case of polyatomic molecules like methane, ammonia and HA2, the geometry of the molecule is also important in addition to the bond formation. See, already I have discussed the shape of molecules. But here you understand, already many things I have discussed. But here you have to understand in a proper way, and it is the right time to understand keeping in mind that you are studying VBT. Valence bond theory, it tells about the overlapping of orbitals. Hence, despite you are knowing, you should understand, we can say, even little things also here you have to understand. Okay. Then here in polyatomic molecules like CH4, NH3 and H2O, the geometry of the molecule is also important. Geometry means shape, in addition to the bond formation. For example, why is it so that methane molecules has tetrahedral shape and HCH bond? HCH bond means carbon hydrogen bond angles are 109.5 degree. Already I told you. And why the shape of ammonia molecule is pyramid like that way, exact region you can understand by VBT theory. VBT explains all the things. Okay, just I told you why you can say CH4 molecule has tetrahedral shape and CHC means carbon hydrogen bond angles are 109.5 degree. This type of explanation is given by valence bond theory. Explanation about the shape, exact, you can say, not exact, I told you last class that finally MOT molecular orbit theory will tell. But this also VBT also tells. The valence bond theory explains the shape, the formation and direction properties of bonds in polyatomic molecules like methane, ammonia,